Hi, thanks for joining us today. Today we're going to be talking about Lesson 8-4, L'Hôpital's Rule. It's spelled in one of these two ways. These are the only two correct ways of spelling his name. He was a French mathematician. In the modern times, this is how you would spell his name, but the top is how he would have spelled his name without the S. I know this seems a little pedantic, but it's important. He deserves to have his name spelled correctly. And it's not El Hospital. It's not the Spanish word for hospital. It's L'Hôpital. Just getting my pen synced. All right, now, so we should have a circumflex if we're going to omit the S. Otherwise, his name should be L'Hôpital. That's how you say it. So, L'Hôpital's rule is a rule for finding some limits that can't be found using algebraic methods. This will become the preferred way of you finding any limit if you have to. If direct substitution produces one of the two indeterminate forms, meaning we get 0 over 0 or infinity over infinity, positive or negative, then we will use L'Hôpital's rule. Again, L'Hôpital's. L'Hôpital's rule says if we have one of these two forms, 0 over 0 or infinity over infinity, then we can take the derivative of the top function and the derivative of the bottom function, and it will have the same limit. Now, this might not seem helpful to you. You'll see in a minute this is very helpful. This will solve problems a lot quicker. Probably then you can either factor, probably then you can rationalize. You must have the limit of an expression which is written in fractional form. It has to look like f of x over g of x. It has to look like a fraction. And I also want to say this is not quotient rule, and it doesn't replace the quotient rule. And you still need QR. This doesn't replace the quotient rule for all those problems where you would need it. If I was taking the derivative of this fraction, I would still use quotient rule. This is different than the quotient rule. This says if we're taking a limit, we can take the limit of the top and the limit of the bottom separately. This is really dangerous for a lot of you who messed up on the Unit 8 test, the Unit 7 test, who think this is how you do every quotient. It's not how we do it. You have to get used to it. If you need practice with the quotient rule, please come and see me. I can help you out. All right, so we have a function like this, and we want to take the limit. Previously, in calc, you would have said, I get infinity and I get infinity. Now, hopefully you know that the limit of e to the x as x goes to infinity is infinity. It's really important that you know that. If you had trouble with that, you should picture the graph of e to the x. If you can't picture the graph of e to the x yet, you really need to get started memorizing. It's a very important function to know. So we get infinity over infinity. That's our hint to use L'Hôpital's. Now, this book was written before the AP test changed its rules. I want to be clear about a few things right now. Number one, if you write equals, you will lose points. If you write that this limit is equal to this, you will lose points. If you write this, you will lose points on my test, you will lose points on the AP test. They banned this officially this year. So you have to get used to that. So please listen to me. Here's what we're going to do. If we notice that we get infinity over infinity, maybe you write it like this, maybe you write next to the numbers. It's kind of up to you. The top's going to infinity, the bottom's going to infinity. What you want to do is write out 3 steps. Number 1, limit as x approaches infinity of x equals infinity. Now that's okay. 2, limit as x approaches infinity for e to the x. That's equal to infinity. What's not okay is equal infinity over infinity. I know it seems stupid. It's the world we live in. So therefore, they want to see that you're checking these two things. Therefore, or thus, or so, this limit equals this limit. And the way I'm going to get this limit over here, we're going to take the derivative of x, which is what? 1. And the derivative of e to the x is e to the x. So these two things are equal by L'Hopital's. And it's okay to abbreviate L'Hopital's like this. If it was a test, I might write it out. It's probably going to be okay to write it as L''H. So by L'Hopital's, since these two things were checked, we can use the derivative of the top and the derivative of the bottom. So now I know this confuses people. So now this one's going toward 1. This one's not changing at all. And this one's going toward infinity. If we divide 1 by a larger and larger and larger and larger number, we are going to get 0. I'm taking 1 divided by a really large number. 1 pizza split with infinitely many people. 1 cookie split with 100 people. 1 cookie split with 1,000 people, etc., etc. So we still get 0. That's it. Done. 0 is our final answer. But you need to write this step, and this step. You need to cite the two reasons. You know the top's going to infinity. You know the bottom's going to infinity. Put another way. All right, so if I do this problem, if I do number 2, what do I notice? I notice that we have infinity for the top. I notice we have infinity for the bottom. That's not okay. That tells you you should use L'Hopital's. But we need to still write out these two limit claims. They're the same exact thing. So, 1, limit as x approaches infinity. And if you think you don't like this, if you think this seems like a drag for yourself, imagine my surprise when I've been teaching it for years and doing it myself for years, all wrong according to AP. This is tedious, but this is what they expect. They expect you to check that the top's going to infinity, probably hopefully written nicer than me. The bottom's going to infinity. So by LH, by L'Hopital's, this limit, the limit we started with as x approaches infinity, e to the x over x equals this limit. Take the derivative of e to the x, you get e to the x over 1. And we try the limit again. The bottom's not changing. The top's going to infinity. Infinity over 1 is not indeterminate. 1 over infinity is not indeterminate. If I have 1,000,000 cookies and I split them with one person, we get larger and larger values. We get infinity over here. So infinity is still a possible answer. 0 is still a possible answer. The thing I want to go over, both of these are infinity over infinity. Do not think, I know where to write this up here. Don't think that infinity divided by infinity equals 1. That's been our slogan all year. That's still 100% true. All right, next. We have example 3. You probably should be able to do this from here on out on your own. You should try each example and then see how you do. Probably pause at example 5 and then check how I did it. Go ahead, try it out. Make sure you're writing out statement 1, statement 2. I know it seems ridiculous. I'll be checking. 3, 2, 1, here we go. I mentally am trying to plug 0 into the top and the bottom. When I plug 0 into the top, I'm getting 0. When I plug 0 into the bottom, did you get 0? That's absolutely wrong. When you plug 0 into the bottom, you should get 1. So this does equal 0 over 1. That's okay. This is not indeterminate. 0 divided by 1, if you have 0 cookies and you split it with one person, you get 0 cookies. Done. What about this? The more nefarious. What does this mean? Do we forget? It's been a while since we've done limits. the limit as x goes to 0 from the left. As we go to 0 from the left, so that's from the left, in case you forgot. If I plug in 0 to the top, I'm getting 1. If I plug in 0 to the bottom, I'm getting 0. What kind of 0 am I getting? 0, on the left of 0, we have some negative numbers. So I'm going to divide positive 1 by quote unquote negative 0. Positive 1 divided by negative 0, I'm getting negative infinity. Now I know for sure a lot of you are forgetting how to do negative infinity like that. It's really as simple as I said. Positive 1 divided by negative 0.1 is negative 10. Positive 1 divided by negative 0.01 is negative 100. As x gets smaller and closer to 0 from the left side, this whole fraction, quotient, whatever, is getting really, really big negative number. Now, were these two surprising? Did you use L'Hopital's on these? Because that would be wrong. If you use L'Hopital's on this one, you will get the wrong answer. You will get 1. If you use L'Hopital's on this one, you will get the wrong answer. You will get 1. Please be careful. You need what? You need 0 over 0 or infinity over infinity. Did that trick you? If it did, try this one more time. See what you get. When I'm plugging 0 to the top, what do I get? Well, 3 minus 3 e to the 0. 3 times 0 is 0. 3 minus 3 e to the 0 is 1. So 3 minus 3 is 0. And the bottom is 0. Again, don't write. Do not write this. If you talk to someone who did this last year, they might say you can. You cannot. You will not be allowed to do that. Don't, here you should have space. Don't write equals 0 over 0 or equals infinity over infinity. You will lose points on it. I will take them from you. So you check mentally that these two limits are going to 0. That's indeterminate. That's what lets us use L'Hopital's. Step 1, limit as x goes to 0. 3 minus 3 e to the x, e to the 3x, whatever, equals 0. You probably already did this check in your head if you're writing this down. I know it feels ridiculous. X equals 0. So since we have 0 and 0, so by L'Hopital's, the limit we started with, and yes, you have to write this part out also. You can't just say, so that, you just can't say anything. You have to say, so this limit equals this limit, where we take the derivative of the top and the bottom. If you really haven't tried this yet, please try to take the derivative of the top, try to take the derivative of the bottom. The bottom's easy. The top, hold on to the negative 3, that guy's 0. Bring down the power, not bring down the power, I'm sorry. Take the derivative of the power. So we should get negative 3 e to the 3x. Exponents copy themselves, and then times the derivative of the power. And here, now we can plug in 0. Because the bottom's not changing, the top is, we should get negative 9 e to the 0 over 1, which is just negative 9. Done. Easy peasy. All right, do not use L'Hopital's just because a problem looks like a candidate for the rule. Examples 3 and 4 are not candidates for L'Hopital's because we do not get 0 over 0 or infinity over infinity. You need 0 over 0 or you need infinity over infinity. Those are the only two options. If using L'Hopital's leaves you with this, you can use the rule again. So that's somewhat new news for you. You can use the rule again. It is a process which can be repeated as many times as necessary. And that's not the best. It's going to be annoying. Just remember to use direct substitution each step to make sure the rule can be used. Make sure the rule can be used again. which means check over one of these two forms. Here we go. Ugly, ugly, ugly. We tried direct substitution. Negative infinity in the top. We have a really large negative number squared. We get a really large positive number. E to the negative x. If you want to do it graphically, we're talking about, gross, too high. We're talking about the reverse graph. We're talking about this guy. And as I go further and further to the left, I'm going further and further up. This is also infinity. So what do I need to write? Go ahead. I guess I didn't give you time to try this. You should try both of these. Make sure you're writing out your proofs each time. 1. Limit as x goes to infinity, negative infinity. That equals infinity. Yes, you already did that trick mentally. It doesn't matter. This is an easy lesson. The hard part is writing this proof nicely. Please write the proof nicely. Please, 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 please. So, and again, this book was built before they made this rule, so you might not have enough space in some of your notes. This limit, I don't care about that. This limit equals taking the derivative of the top and the bottom, 2x. What's the derivative of the bottom? It should be negative e to the negative x. Mentally, we're going to check. As I go toward negative infinity up here, I'm getting negative infinity. Picture a line. Picture going very far left on the line, going toward negative infinity. This guy has flipped the graph, or you can remember that this part is going toward positive infinity, so the whole thing is going to negative infinity. Guess what? You need to state the rules again. 1, limit. X goes to negative infinity. They really care this year that you guys are checking your hypotheses. This counts as a hypothesis. That equals negative infinity. And what we just checked. Now I know I'm going through these limits kind of quick. If you want to brush up on your limits, please come see me. We can do a lot of work to brush up on this. It's still an important skill. This should make it easier, except it's a little more tedious with the rule checking. So by LH again, you don't really have to say again, limit, should you go back to the old one? You don't have to go all the way back here. You do have to write this one out again. 2x over negative e to the negative x equals, we're going to do the derivative again. We're writing the limit each time. A bunch of you are still writing your limits all screwy. It's not equals limit. Sorry, it's not limit equals whatever. You need to write equals limit. It needs to be like this. Derivative of the top is 2. Derivative of the bottom, cycled around. The top is going to stay at 2, The bottom is going toward infinity for sure, just like it was up here. And so we're going to get 2 over infinity, 2 cookies split by a million bajillion people, 0 people. You effectively get 0 cookie. Done. Is it annoying? Yes. Is it doable? Yes. Now 7 is a real big trip. I'm going to get more room. I'm going to clear all this off. 3, 2, 1. All right. Now for 7. Go through carefully. Plug in 1 to each of these things. Natural log of 1. 3, 2, 1. Did you try the whole problem out? Please try it out. All right. Natural log of 1 is 0. Minus 1 plus 1. Definitely going to equal 0. That's okay. Writing that equals 0, that's true. 1 minus 2 plus 1 also equals 0. So what do you need to write? Unfortunately, you need to, and you're probably going to write this over here. You need to write 1. Limit x approaches 1. natural log x minus x plus 1 equals 0. 2. Limit x approaches 1. X squared minus 2x plus 1 equals 0. So, by L'Hopital's, our original limit I miss the old days. Trust me, this might get you points. This might be the difference between a 4 and a 5. It's real. I'm not making this up. I can show you the example in class. Probably will. What's the derivative of the top? Quick. What's the derivative of natural log x? It's 1 over x minus 1. That guy goes to 0. On the bottom, we get 2x minus 2. Top is going toward 0. Bottom, you guessed it, going toward 0. Oh no. Woe is me. Limit x goes to 1 of the top. 2. Limit x goes to 1 of the bottom. So, by L'Hopital's, limit x goes to 1, 1 over x minus 1 over 2x minus 2 equals the limit. Look how I'm writing the limit every time. It's not because I'm having so much fun doing it. It's because it's necessary. 2 on the bottom. I'll give you a second on the top. You might want to write this as x to the negative 1. For derivatives, that's good to have. For integrals, 1 over x you need to recognize. For derivatives, you probably want to write it as a power. What is it? It's negative 1 over x squared minus 0. Work it out. See? Okay, I just simplified it. Now we're getting 1 minus 0, negative 1 minus 0, and the bottom is going to 2, so negative 1/2. And that's your final answer. That's all there is to it. All right, now I'm going to do one more example. This is from 8-3's homework. People found this enlightening. I want to emphasize again, the most common type of limit problem on the test is usually this or this. And if you haven't done this problem from 8-3 yet, pause the video, try this out, at least think about how you would think of it. I'll wait. 3, 2, 1. So nowadays, and I say nowadays like you've been doing this forever, you might try L'Hopital's on this problem. That would not be appropriate. If you do L'Hopital's on this problem, you do get 0 on the bottom and 0 on the top. Quick, you can check me. This is t, this is root t, we're subtracting it. You could do L'Hopital's. You would differentiate with respect to t, or sorry, to h, and that would be a pain. I even messed up saying it just now. But you don't want to. This is a weirder problem. If f prime of t equals all of this nonsense, they're asking you to find f of t. Asking you to find f of t. You need to remember that this is the limit definition. I don't know why I'm going to erase that. This is the limit definition of a derivative. Which, in case you forgot, anytime you see limit h goes to 0, that should be the trigger for you. If you see this limit, it's a limit definition of derivative. What's supposed to be f of x plus h minus f of x all over h. That's f prime of x. So if you want to find f of x, all you have to do is look over here. What's being subtracted? All you have to do is look over here. What's being subtracted? And f of t will make you feel really stupid if you worked really hard on this problem last night. That's it. Now, what if they asked you to do f prime of t? Well, first you would find that, and then you would do this. Because they don't want you to evaluate this limit. It'd be a huge waste of your time. it would separate you from someone who's getting a 5 for sure. But they asked me for this, not that. That's how you do that problem. You should be able to do all these problems on 8-4 homework. Congratulations. That's really the last calculus technique, and we go all the way back to derivatives and limits. Everything from here on out should be following action, trig review, and doing everything we did in the last 8 units with trig. Congratulations. Have fun on the homework. Thanks for watching. Have a great day. Have a great night. Bye-bye for now.